Mrs. Sushanta Basu's son, Sudeep Basu, also joining us here. Mrs. Sushanta Basu was born on 19th of January 1948 in Kolkata to late Mrs. Sachindra Kumar Basu and Mrs. Namita Basu, and has his siblings Mrs. Malavika Ghosh and late Mrs. Madhavika Ghosh. Mr. Basu was a naval architect who passed out from IIT Kharagpur in 1970 and initially joined Hindustan Shipyard. Thereafter, he joined IRS in the early 80s and spent many years until his retirement from IRS. Post-retirement, he settled in Goa and was very actively involved in educating youngsters in Goa Shipbuilding Institution and Goa Maritime Association. With his untimely departure, the naval architect's profession has lost a very dedicated, knowledgeable, and a very loving senior amongst us. May his soul rest in peace. With this, I would request Mr. Basu's batchmate, Professor Sst Mishra, to kindly speak a few words about Mr. Basu.
Good evening to all of you. Am I audible?
Yes, please.
Okay. I mean, Sushanto is no more. It's rather difficult to imagine this, but that happens to be a fact. Sushanto Basu joined the Naval Architecture Department of IIT Kharagpur. Along with a few of us, I think that batch was initially 20. In 1965, 65 makes it more than 50 years. It's about 56 years now. He was at the RK Hall of Residence. He was nicknamed Revo by his friends. I really don't know how this name Revo came about. Perhaps it's a short form of the word reverend. And that's because he was one of the so-called good boys, always helpful in nature and trying to help anybody who was in distress. After passing in 1970, we did a 5.5-year course, and the course ended in 70 December. In 71 beginning, me, P.P. Singh, P. Sambandhan, and Sushanta Basu, 4 of us joined Hindustan Shipyard. Sushanto joined the ship repair department, and 3 of us joined the ship design organization. However, we all stayed together, sometime in the same house, sometime in houses next to each other, and we are very close as friends. In 1973, I left for UK to do my PhD. Sometime after that, when I was not there, Sushanto married a Vizag girl, Deepu. After my return in 1976, I got married. And by that time, Sambandhan had left for IIT Madras. And 3 of us, PP, me, and Sushanto, with our families, we stayed very close to each other and became very intimate with each other. Around 1979, 1980, we all left Hindustan Shipyard. I left for IIT Kharagpur, and Sushanto and PP Singh left for Mumbai to the Indian Register of Shipping, the IRS. Sushanto served in IRS till his retirement age of 60. And during his professional career there, he not only made a name for himself as a good surveyor, but made lots of friends, which is obvious from the number of obituary messages that have come about after his demise. His last posting was in Goa. He purchased a flat there and settled there. Deepu was an English teacher in the Shipbuilding Institute of Goa, and Sushanto was an occasional teacher there teaching shipbuilding. This is the institute called ISBT. He has also been a member of the managing committee of ISBT Goa. Both Deepu and Sushanto have many student admirers in Goa, And when I went with my family to Goa to visit Sushant and Dipu, I was surprised to find almost half of Goa knew them. Everywhere they went, good morning, sir, good morning, madam, was continuously going around. Everybody had a smiling face and they kind of recognized them immediately. This was quite revealing to me. I didn't know they were so very popular. Also, they are very prominent members of the local Bengali community. His father had expired earlier, and his mother was with him throughout, a very homely lady. My wife and I were fortunate to be their guests and take the hospitality of his mother in Goa. I served as the director of Indian Maritime University Visakhapatnam campus between 2009 and 2013. During that period, I invited Sushanto to become a visiting faculty for shipbuilding there. He gracefully accepted the offer and used to come once a month to Vizag, where I used to meet him. After my retirement in 2013, I was also invited to become a visiting faculty at IMU Vizag. This continued for 2 or 3 years more. And whenever I visited Vizag, many times Sushanta was also there doing the visiting faculty job. We used to stay in the same guest house and we had a very fruitful interaction during those periods. Sushanta was so popular with the students, you can't believe it. He was a postgraduate student, postgraduate teacher, but the undergraduate students came to him, requested him, sir, you must teach us shipbuilding. I think Sushanta took a few lectures on an honorary basis with the undergraduate students. This was quite revealing to me that he was such a good teacher, that he was appreciated by students who had never heard him, but heard from others that he was so good and requested him to come. He has one son and through him 2 grandchildren. His son's name is Sudeep, who after graduating from Bombay University had moved through IIT Bombay and University of Louisville, USA. He is a biotechnology person. He is currently with consulting firm Frost & Sullivan and also a guest faculty with the Rutgers University. Sushanta was a very amiable character and very affectionate. The way he took care of his parents is really admirable. His mother, a very homely Bengali lady, survived her husband and stayed with Sushanta till a ripe old age, above 90. Sushanta was always by her side. In fact, many invitations, including one of the alumni meet of his old school, St. Lawrence, he regretted attending because he wanted to be with his mother continuously. This was revealing to me. I came to know this only after his passing away. His wife Dipu has been a strong and courageous lady who gave him support and company throughout. Suffering in ICU for such a long time was really painful for Sushanta as well as for Dipu. His passing away is quite untimely. 72, 73 is no age for passing away in these days. But perhaps the illness made it inevitable. I can only pray that let him be at peace wherever he is right now. Thank you.
Say a few words. You need to unmute yourself, sir. Mr. Savan.
Okay, can you hear me?
Yes, we can hear you.
Yeah, thank you. Thank you, Dasgupta. And dear friends, actually, Dr. Mishra has spoken so much about Sushanta that there is hardly any scope for me to tell anything much more about him. But then I can add a few things like, actually, I met him first was in Sudhir Kumar's cabin in MMD in Bombay. And I found him to be very jovial, very outgoing. And so since then, of course, I couldn't keep in touch with him then. But then when I moved to Goa in '87, that's when I started interacting with him. That time he was the IRS local surveyor. We did a lot of surveys together. A very strict surveyor, very meticulous, methodical, explained to the workshop what all works to be done. That was one of them. Secondly, of course, over the years he mellowed down, but and as Dr. Mishra also said, he was very popular with ISBT students also. I still remember him because quite a few of his students have worked with me, and they always remember Shushanta. Wherever we met him, they met him on the street or in the functions. He had some talks with them. Another thing is he always loved to read books. So he would ask me, "Have you read this?" And I told him, "No, I'm not. I'm not such a good reader as such." So over the years, right from '87 onwards, whenever he was with in Goa, we used to interact very well, very often. There was Mr. Sundarlal who was here. Then Sabya Sachin Mukherjee, who was my classmate. So we would have get-togethers very often. In between, there was Devashish Datta, who was ABS surveyor. We even went out. We used to have outings once or two times a year. We went to Murdeshwar and other places. Or visits to the beach were quite often. So, of course, when he was in ICU, I happened to be in Pune, so I could not really, of course, they would have not allowed me in. I was in touch with Deepu all along. But then suddenly, one fine day, she told me that he's no more. I mean, he was gasping for oxygen and he's no more. That was really sad, having known Basu for so many years, so close. But that's it. I mean, I only pray let his soul rest in peace. Thank you, Das.
Thank you. I personally have felt a sense of loss because I had very nice memories of Mr. Basu, although most of the time I was at the IRS head office, but we had very nice exchanges. And he was so amiable. When he met somebody, he was always known amongst all the colleagues as Goa Basu. So there was a new guy who had joined the office, and he came to the office and he met Mr. Basu. They had exchanged emails earlier. And then he introduced himself. "Don't you know me? I'm Goa Basu." You know, that was the kind of free feeling that he had, and for everybody, and the love and affection that he exuded all around, all the time. We are really honored to have Mrs. Basu Dipudi and Sushantoda's son Sudeep all the way very early in the morning from US. Our heartfelt condolences to you from the institution Naval Architects. And we sincerely pray that you get over this immeasurable loss very soon. And we all shall hold Mr. Basu forever in our hearts. May his soul rest in peace. Om Shanti. Thank you very much. Thank you very much. With this, I shall, I conclude the remembrance session for Mr. Sushanta Basu, and I would request Mr. Akshay Jain to take over to carry on with the technical session. Thank you.
Thank you, JD sir. Thanks a lot, Mr. Dilip Sawant, Professor S. Mishra, for sharing your remembrance from Mr. Shantanu, Mr. Shantanu. I have never met him. I never had an opportunity of meeting him earlier, but Such platforms here gives us a lot of introduction to the senior naval architects and the contributions they have given. So we're thankful to you, both of you, to come here and to present that. As a part naval architect, as an institution of naval architects, one of the objective what we have is to disseminate knowledge across the industry and to give opportunity for various different research and activities being done by industries and academia to share it with the other industrial colleagues, and hereby making them aware of various different activities going on. So today we have a similar topic here. In recent past, we have done various different webinars. We are trying to have one webinar every month. We have had webinars on development of Visinjam Port, innovation potentials on the emerging decarbonized and blue economy, East Coast canal systems, and shipbuilding prospects post COVID-19, etc. So that we have been doing one webinar every month. So today, the topic of webinar is Marine Research Undertaken in Fluid Dynamics at IIT Delhi. This will be presented by Professor Sst Singh. The session will be chaired by eminent Professor Shenoi. I would like to briefly introduce him. So Professor Shenoi is a professor in ship science at the University of Southampton. He is founder and first director of Southampton Marine and Maritime Institute. He graduated in 1974 with a degree in naval architecture from IIT Kharagpur. Between 1974 and 1978, he worked successfully in Mazagon Docks, Bombay, and Arya National Shipping Lines, Tehran, before returning to academia to the University of Strathclyde in Glasgow, from where he obtained his doctorate in 1981. Since he was been at the University of Southampton as lecturer, senior lecturer, and reader and professor. He is a chartered engineer, being a fellow of the Institution of Naval Architects, Institution of Marine Engineers, and the Royal Institution of Naval Architects. The principal subject of his research studies over the past 40 years has been on the advanced materials and structures in ship design and production. He has published 15 books and over 300 papers in journals. He has also authored 3 patents. The practical impact of his research has been in new design standards and production processes for advanced composite materials and structures in ships, boats, and submarines. Industrial collaborators for his research include regulatory bodies, shipyards, shipping companies, material suppliers, the Royal Navy, the Royal National Lifeboat Institution, as well as maritime engineering consultants in UK, Europe, and Asia. He has received medals and prizes for his work from Institute of Petroleum Scotland and Royal Institution of Naval Architects. He was awarded industry fellowship from the Royal Society and the Royal Academy of Engineering, and he has held visiting professorship in several universities in UK, Netherlands, China, India, Japan, and Singapore. He is particularly honored for being invited as a scholar in residence in ship technology in QCET in 2012 under Kerala government's erudite scheme, and to have received the Distinguished Alumnus Award from IIT Kharagpur in 2019. With this brief introduction, I invite Professor Shenoi to chair the session and take the proceedings ahead. Professor
Shenoi. Thank you. Can you see me and hear me?
Yes, sir, we can hear. Go ahead.
Thank you. Thank you, Akshay, for the introduction. So the topic today is very, very apt, considering the remembrance that we've just had to Mr. Basu, in the sense that it covers both academic research, as in teaching, as well as industry. And we are very fortunate to have with us very eminent industrialist, Mr. S.M. Rai, as the chief guest. And we're also privileged to have with us a very eminent scholar from IIT Delhi, Professor S.N. Singh. What I'm proposing is to introduce both Professor Rai and Professor Singh straight away. And then I'll invite Mr. Rai to say a few words to set us on course for today's session, following which I'm hoping Mr. Singh will give us his talk and share insights into his research. And then hopefully that will take about 40 minutes or so. And after which we'll have the floor open to the participants for the question and answer session. So that is briefly what is in store for us over the next hour and a half or so. So if I introduce Mr. Rai, many, if not most of you will know him. He's one of the most senior members in the marine engineering fraternity in India. He graduated in engineering from Jodhpur University way back in 1970, I think, and then joined the Shipping Corporation of India. And he worked there for a number of years on board ships before being inducted into the head office in 1980. In the head office, Mr. Rai headed several technical departments. So he's clearly made his way around the shipping organization practically. On superannuation, he served as the director of the Indian National Ship Owners Association and is currently assisting industry as an advisor and consultant. So he's still very, very active and sharing his knowledge and wisdom with industry and with all of us. He represents stakeholders on technical committees and forums, and he has represented India on a number of occasions in the International Maritime Organization and the United Nations. He's been chairman of the Institute for Marine Engineers for a number of years, and he still continues to be actively involved in its activities. So with that introduction as Mr. Rai being one of the most senior and distinguished members of marine engineering in India, we are very honored in Institution of Naval Architects that he has agreed to grace our forum by being the chief guest. I think with that, perhaps I will ask Mr. Rai to say his piece at the beginning, and I'll introduce Professor Singh just before his talk. So Mr. Rai, if you want to unmute and put your video on, and if you could please say a few words to us. Thank you.
Thank you, Professor Shenoi, for your very kind and flattering words. And to start with, Shri Das Gupta, Professor Singh, Professor Shenoi, Professor Mishra, members of INA, my dear friends and colleagues. It's an honor to be invited today to this webinar, and I consider it to be a privilege to be with you all today. It's an opportunity to hear Professor Sst Singh from the Department of Applied Mechanics, IIT Delhi. I will be honest to admit that it is very rare that I get a chance to hear to the professors and academicians. So today will be a learning lesson for me too. It is indeed, today I will know something about his vast research works and support he has extended to the fraternity in this field. I did read something about his past research works, etc., and it spoke volume about his interest and the work that he has done. The extensive research work that he has done for the Indian Navy and marine application makes very interesting reading, and we await his sharing of some information with us today. As Akshay rightly said, his talk today will be basically on fluid mechanics and the research work that is being done at IIT Delhi. During question answer, of course, I will have some questions to him regarding research work in the field of the maritime sector as well. Those who are from Merchant Navy today in this webinar, I'm sure can also learn and grasp many things for not only operations, but construction of commercial ships as well. I can share, talking about research work, that International Maritime Organization is also lately seriously considering to float a maritime research board and research fund, particularly related to these environmental issues and cost that it is causing to the humanity, particularly due to the pollution, whether it is air pollution or sea pollution. So they are, they are considering to float a fund to go into the research, particularly to look into alternative fuels. I will ask Professor Singh later on if IITs or Delhi IIT is looking into any possibility of doing research in that field. Professor Shenoi, a chartered engineer, I had a pleasure of meeting him today, is chairing the session. And I noticed that he himself has done a lot of exemplary work in the ship science and related maritime field. I only request him that please make us understand the intricacies of Dr. Singh's presentation today. Talking about INA and IME, I can recall decades of our close association, though because of COVID, pandemic, and other related issues, last few years we have not been associated very closely. But as I requested to start with, I hope with Mr. Dasgupta, Akshay, and all are there, we should be working more closely. Institute of Marine Engineers also holds regular webinars on current topics, and I'm sure we can join our hands and do that. I will talk about those with the organizing committee of the INA after or in due course of time. Today, let us wait and hear what Professor Shenoi and Professor Singh has to deliberate and present it to us. With those, I wish webinar and INA all the best, and let us hope that we have a very interesting interactive session. Thank you so much, sir.
Thank you so much, Ms. Rai. That was really, really excellent introduction to the session. Thank you. And we'll look forward to your inputs during the question and answer session as well. So we'll look forward to more from you then. But I now turn to introduce Professor Singh, who is an engineer, graduated from IIT Kanpur, both bachelor's and master's. And then he came to IIT Delhi, from where he did his PhD. He's been in IIT Delhi since 1979, so it's a long time he's been there, and more or less made IIT Delhi Applied Mechanics Department and so on. So he's been there as a research engineer, as a lecturer, as an assistant professor, associate professor, and a professor for many, many years. The fields of his research is quite a broad-ranging field in fluid mechanics. So it's applied mechanics that he's worked in. And on the fluid dynamics side, working on internal and external flows, computational fluid dynamics, turbo machinery, two-phase flows, experimental techniques, and so on. It's a long list. He's got a very deep CV, so I may not be able to do justice to him in this very brief time that we've got for the introduction. But he's published very, very extensively in international and national forums, in journals, in conferences. He's been a speaker much in demand in several universities and several places to deliver lectures. He's been a great teacher for undergraduates as well as postgraduates. So I note that he has supervised more than 100 master's projects and about 30 PhD students. So that's a significant number as a teacher. He's received several sort of prizes and awards, and is internationally known for his contributions in fluid mechanics. So again, we are very, very privileged in the Institution of Naval Architects that Professor Singh has agreed to join us and to share some of his knowledge and wisdom in fluid mechanics with us. Professor Singh, please.
Professor Singh, I believe you are on mute right now. Yeah.
Yes, can you hear me now?
Yeah, we can hear you now. Yeah.
Okay, this is primarily, thank you very much, Professor Shenoi and Professor Rai. I would be talking about my research shortly, but I will give you a brief of how did I come to doing research in the area of marine. Way back in, if I share the, can you share this?
Yes, so we can see the screen. Yeah. No.
Okay. So before I start, what I will do is, I was talking of how I was dragged into doing research related to ships. I will go to, where is that? This one. So way back in, if I remember correctly, in 95, 96, Indian Navy approached us and they wanted some solution to the problem which was faced by the ship, which is the smoke nuisance problem, which we really named it as. And that is what is being shown here. So when they had gone around the world, what they found that the intake temperature of the gas turbines was higher by 2 to 3 degrees, and hence the efficiency of the engine was down. They came up with this problem, and it is at that time that I got involved with the aerodynamics of ships. It has been an interesting journey, but and then there was another issue which came up, which I think was to do with trying to make the Naval Research Board understand that it is not only hydrodynamics, it is also aerodynamics which is important for ships. And you won't believe, it took us nearly 3 years to convince them that they need to give credit to aerodynamics. So that is how I got introduced to the field of marine research. And since then, it has been a very pleasant journey. On the way to this, I've been able to supervise 8 PhDs related to the marine research. So I'm going to talk about them slightly, each problem, what we have done. And then I will not go into the details because it will basically, maybe for some it becomes slightly boring. So I will try to only highlight the findings which we were able to achieve through our research over the past 20 years or so. So coming to the presentation, I will basically talk in terms of why research is important, and then tell you what are the facilities which we have, and then go into the problems which we have been trying to investigate. Why I say it is importance of research, and specifically in the area of marine. See, the amount is spent in building ships is huge, and the time taken is huge. And if we do not take care of the problems at the initial design stage, we might be forced to do a lot of retrofitting, which may not be desirable. And why I am saying that, that is what we learned when we were doing to find a solution to the smoke nuisance problem. So it is with that that I basically feel that some form of research is very, very important. Related, there is many research areas which ships have, and they have been going on, but somehow the aerodynamic aspects have been neglected for too long, and they need to be put into place and given due importance in that for research in the area of marine. So why I say that, the issues with design and operation of marine vehicles from aerodynamics perspective, because if you see, if we do not understand the fluid flow problem, how it interacts with the dynamics of, let's say, a landing helicopter or a landing aircraft on an aircraft carrier, and the operation of the ship itself, and also the requirement of stealth today. So it becomes very important to have one of the focus areas as external aerodynamics on marine vehicles. The second important aspect is, because if we have to do research, we also have to ensure the feasibility and the scalability of the solutions. And now here comes a very important issue. Most of the institutions in India have very limited facilities as far as marine research is concerned. I can say the biggest tunnel which we have is an IIT Bangalore, which has a cross section of about 20 feet by 20 feet and a length of about 20 feet. That's the information. Then there is another tunnel at IIT Kanpur, which has a cross section of 7 feet by 9 feet and has a test section length of about 30 odd feet. And then there are various tunnels. The IIT Kanpur tunnel is far most the best in that sense, because they can achieve a velocity of air at least about 70 meters per second. All the other tunnels in the rest of India have a varying size from 2 feet by 2 feet to 5 feet by 5 feet. But the velocities are most of the time in subsonic range, except for NAL, which has a transonic wind tunnel, which is 4 feet by 4 feet. So that is the background which I thought will be important to see why we have this. So as far as facilities concerned at IIT Delhi, we have various wind tunnels, and majority of the tunnels have been built in-house. And we have all these sophisticated instruments for measuring the velocity, starting from impact probes to particle image velocity meter. We have all those instruments and we have a very dedicated computational lab. And we have also the facilities in the Institute of High Performance Computing. So we can do a lot of work both in the area of experiments and computational studies. So now, having given a brief background, I will start talking of the problems which we have investigated at IIT Delhi. Exhaust flume studies, which was originally came as a consultancy, and subsequently 2 PhD students from the Naval Architecture fraternity did their PhD. Then we had some studies on the exhaust diffuser studies, and one of the naval persons did his PhD. And subsequently we continued and we did lot of about 2 or 3 more PhDs on from regular students. The subsequent problem which we analyzed was the SFS, the frigate ship, and what are the issues associated with the frigate ship with and without the downwash. When we say downwash, we are basically talking when the helicopter lands, what effect does it have on the flow characteristics created on the ship due to the different bluff bodies located on the deck. And then we started working on the aircraft carriers, and still some work is going on in the area of aircraft carriers. So let's see how we do it. So these are 5 steps which we have generally followed in our research related to the marine vehicles. These could be the first 2, flow visualization and experiments, could be reversed, that you do experiments and you find something which you are unable to explain on the basis of the experiments, and therefore you try to see what exactly is happening to the flow that your measurements are unable to pick up. So we have been doing flow visualization using tuft probes and smoke visualization. And once we have done the experiments, and this is true for all the problems which we have tried to handle here, we basically do the CFD simulation, and based on the in-house experiments results and some reported results in literature, that we optimize or select the optimum turbulence model which will suit the configuration and which is identical in some sense. And that allows us to do, once we have validated, the parametric investigations at a much faster pace compared to experiments. Because experiments, all said and done, are very cumbersome. And CFD helps us to overcome those limitations. And we can very easily even scale up the, once we have validated the CFD code, we could do parametric investigation at lower scales. Like generally when we do experiments for any ship, the size of the ships are too big. So we scale it down to maybe, if it fits and not create too much of blockage in the wind tunnel, the scale could be 1:100, and it could go as high as 1:300. But when we have to do with CFD, and if we have the computer power and the storage, we might solve the problem in the actual condition. Or otherwise, if we feel that the limitations are high, we could talk of doing it at 1:50 scale. And because the basic parameter of scalability in our studies for external aerodynamics is the Reynolds number. So if we achieve a Reynolds number, which we have seen by our experiments and other things and CFD, that if you have a Reynolds number of more than 10⁵, there is not too much change in the flow structure around a ship. So with that, so these flowchart explains how we have basically carried out the research. And in general, this is applicable for any field, not very specific to marine research, but we can do it. So now let's go one by one. This was the first problem which we faced, was that the ship had already been constructed, and they found that the intake temperature was of the gas turbine was increasing, and we were looking for a solution. And if you see the flow which is taking place, the suction point for the two gas turbines was just located upstream of the exhaust flumes. And the smoke coming out of these flumes was being sucked in. If you see the flow structure which is being shown, where the flow is upstream is also being sucked in, and as from the front system, as it travels, it is sucked by the second intake. So that is why the temperatures were going up. We did give them a solution, and that solution worked. And what we gave them the solution was to modify the exhaust of the flume and divert the flow. And that is what was done for both. And it solved the problem also. But then we wanted to go into the detail of this, because subsequently we also came to know that it interfered with the aircraft operations. So we started this. The prediction of flow around the superstructure and the smoke superstructure interaction is extremely complicated, since the phenomena is affected by a large number of parameters like wind velocity and direction, level of turbulence, turbine gradients, geometry of the structures on the ship deck, and efflux velocity of smoke. So the superstructure design on naval ships primarily involves an aerodynamic study of the wake of the superstructure. So this is where it becomes very important to have a fair knowledge of the aerodynamics of the flow characteristics over marine vehicles. The ship designer at the initial stage itself needs to be able to have a means of visualizing the path of the exhaust under different conditions, rank the relative merits of different superstructure configurations, assess the suitability of air operations. So what we need: wind tunnel modeling, field measurements, analytical methods, or using CFD. These are the options which are available to us. Wind tunnel modeling, as I told, the type of facilities which we have, the scaling plays a very important role. And hence, we should also be able to make sure that if we convert the findings at the experimental stage to the prototype. So therefore, to do this, the type of parametric investigations which we did, this is just to give you, we simplified the top deck structure with different configurations, only having the exhaust plumes in line, stagger them, put the superstructure, put it in between, put it ahead, and all those configurations were investigated. In total, it was about 112 cases which were carried out. Not all by experiments, but using experiments and CFD. So this is how the model in the wind tunnel was simulated for a computational domain. So you can see this portion. This is basically the wind tunnel cross section, and the model with the thickness above the sea level, the surface of water, is simulated, and measurements were taken, and the visualization for smoke was done. And this is how I'm not going to go into deep of this. We basically developed the computational model. And now if you see the smoke visualization. So please forgive me, because the smoke visualization is being shown in one direction, whereas the CFD simulations are being shown in the other direction. But if you see the results by CFD, it really picks up very well the flow structure over the simplified deck in all the cases. So if you see, there are different parameters which we have used, and see the comparison of the smoke with the path lines which have been generated from the CFD simulations. So it really matches quite well with the actual practical flow structure which happens on the ship. So, and now you see how, with the help of CFD, if you see this, the structure being placed ahead of the flume, how does the flume actually lifts up drastically, because it falls in the wake of the superstructure and does not disperse, and therefore it lifts up higher in the atmosphere. And even the CFD picks it. And even if I have the system, the small smoke entering into the reverse flow can also be seen in the CFD simulation. So this is how the actual flow behind one of the exhaust flumes can be seen. And as we vary this, and now this second one actually shows the interaction which is going to take place between the two flows of the exhaust flumes. So now if this has been known in the initial design stages, one could very easily decide, and which may not interfere with the operations of the ship, the locations to how to place the exhaust flume or the superstructures. So there were modifications suggested for avoiding the smoke nuisance problem through this study. And this study was done by 2 students. One of them today is a professor in IIT Madras. Coming to the second problem, which I'm not going to go into too deep. This was also work done on a submarine to evaluate the hydrodynamic coefficients, establish the maneuverability of the submarine. CFD helps you to predict the hydrodynamic coefficients, and we used the existing results in literature for validation, because doing experiments on submarines in IIT Delhi was not feasible. So we used the results which are available in literature to do the, and then did a sensitivity analysis of maneuverability coefficients with respect to definitive maneuvers which a submarine is supposed to take. So this is again how the CFD domain and mesh was done. And it was done in blocks, so that one block, which basically had a very dense meshing close to the submarine, was in an elliptical cross section, so that this block could be independently rotated to get to the different maneuverability positions and see how the flow behaves. So these are some of the results which were obtained on the hydrodynamics of submarine. So now we come to the ship airway halodeck flow field for safe halo operations without downwash. So this basically, we took the model which has been established to represent the flow over the frigate ships and classified as SFS-1 and SFS-2. And because it involves a lot of issues, because there is a huge investment and the construction of the ship and the aircrafts, it is very important to make sure that the operations do not, of the helicopter and others, overload the pilot while he has to land, or there could be accidents. So today what we are trying to do is a very experienced pilot tries to establish the safe halo operation limit on the deck, which is very tedious, and the ship during that period remains out of service. And hence, we felt the need to do some studies to establish the flow structure and how it is influenced by different parameters, so that we could do detailed parametric investigations using CFD. And this needs to be done at the initial stage of design, because any modifications subsequently are time consuming and painful and impose constraints on the operation of the ship. Yes. So the aim of the present research, part of research, was to investigate the flow structure on prevalent helideck configuration of frigate form of ships through experimental and numerical methods, and identify flow parameters defining the structure. Formulate a methodology for numerical evaluation of the flow on the helideck, and then arrive at some set criteria which, if met on the frigate ship, could lead to a safe helo operations. So, which was basically the aim was to identify solutions which can be effectively used to tailor make the superstructure wake on helideck to improve conditions for helo operations. So, what we did in the experimental analysis, both quantitative and qualitative data was generated experimentally by taking mean velocity measurements using impact probes, a 5-volt probe, and to do flow visualization studies on the scaled model of the frigate, and different geometrical changes and dynamical conditions were tried to see which gave us the best results. One of the questions which could be raised today, you have done this, are these feasible changes on the frigate ships? A question which needs to be answered by seeing the actual workings. So, the different configurations which were geometrical of hangar were done, and some dynamical. So we will go one by one. In the active devices, we tried to deflect the flow over the hangar or use a rotating cylinder to suppress the zone of separation just downstream of the hangar. And while doing this, we also needed to find the criteria for comparative assessment, which is going to give a better flow characteristics for safe helo operations. This is a study which is being done without considering the helicopter. The flow which the helicopter pushes onto the at the time of landing, we did not simulate that in this study which we did, but subsequently we did try to model the helicopter downwash using a simplified rotor downwash. So this is primarily the model which you see. which we considered. And this is the wind tunnel which was used for doing this study. And the same wind tunnel was even used for doing the smoke nuisance problem, because we wanted to take a lot of measurements. Whereas the initial work, when they approached us for the smoke nuisance problem, that was done in 5 feet by 5 feet cross-section tunnel, because we wanted to ensure the minimum effect of blockage while doing that study. So this basically gives us the details, and if the blockage in the tunnel remains less than 5%, we don't need to do any corrections. So this is what was done, and this is the planes. It shows the planes at which the measurements were taken. See some vertical transverse planes and some horizontal planes where we took the measurements. And this basically gives you the hangar configurations. Instead of the bluff block, we try to modify the hangar configurations. And this is the one with the rotating cylinder. So we did this study, and I will not go into the detail of how we performed this because it will take too much of time. But let's see, we used different cameras to capture the flow visualization. And having done the validation against the in-house experiments and flow visualization, the Sst Turbulence Model was selected for the CFD analysis, or the transition SST model. And this is the, I am not going to go into the depth of this comparisons because explaining this will take too much of time. But having done this, let me come to the basic system. One of the results which, if you see the rotating cylinder, you see how strongly the rotating cylinder suppresses the reverse flow downstream of the hangar. It reduces it drastically the length of the recirculation zone on the halodeck, which basically implies practically that a larger portion of the halodeck is available for landing. So all this was done. You can see the comparison of the CFD and the flow visualization. So if you see, this is with some rotation, this is with increased rotation. The cylinder can be seen, that this is the cylinder which is rotating. The smoke has been injected upstream of this, and how it basically gets into the, so if you see, as you increase the value of the beta, the velocity ratio primarily, it basically helps you to reduce the recirculation length. So the overall assessment for the cylinder, there it basically introduces dramatical changes which are very favorable. The length is reduced. There is no significant change in the turbulence level by introduction of a cylinder. Criteria of downdraft nearly remains the same. It does not. Therefore, significant increase in the mean of vertical velocity component on lower planes, which support the landing. And the uniformity of the flow over the helideck. So it is expected that if we could have such a system, it will lower the pilot efforts scale. So this is basically the conclusions which were drawn. The two important, one is the cylinder, rotating cylinder, and the other important criteria which we could see is the hangar configuration. See, the hangar configurations with slight taper on the sides do improve the flow characteristics over the helideck, whereas the plate on the top of the hangar really did not help improve the flow, but needs slightly more investigation to understand why it doesn't help. So I'm not sharing the results which we have done for the downwash because the thesis is still under evaluation. So I'm not going to share those results where we have the downwash of the helicopter and done similar studies to see how does the flow characteristics change on the helideck. And now the last study which has been done is the Airway Studies. And the primary aim of this study was to identify the bubble effect, which is basically with a change which takes place along the landing path of the aircraft, just about 500 meters downstream of the aircraft carrier, along the 3 degrees glide path, which is generally taken by pilots to land the aircraft. There is a sudden dip in the axial velocity, and when the aircraft passes through that bubble, suddenly loses some lift and has a tendency to deviate from the landing path. And that is where now, because this is just located about 500 meters away, the time left for pilot to take any corrective measures is very small, and hence all his abilities are put to task. So the aim primarily was to really see it, and is it possible to eliminate it? If not, can it be pushed down so that the pilot has more time to take corrective measures? So to achieve this objective, we did develop a benchmark aircraft carrier for research, did the velocity and pressure measurements over the top deck of the aircraft carrier with and without the island, and did some parametric investigations by covering the notches provided on the top of an aircraft carrier. So if you see why the flow is affected on the aircraft. So if you see, these are the vortex which are generated. These are the vortex which are generated from the bow and the notches at the top. So this is a few, and this is because of the island. So, and if these two interact, as you move down, they will interact. And then they create the bubble along this path. And hence, we need to see how one could identify and suggest some changes which will help to either delay the bubble or reduce the impact of reduction of velocity which takes place. So this, keeping in mind, this is how basically, so we considered the different aircraft carriers which exist and developed a generic aircraft carrier. So aircraft carriers which we did not have a ski jump, whereas India generally uses with the ski jump, which also presently we are doing some studies with the ski jump, and should be able to throw some light on that. So this is basically the generic aircraft carrier which was made, fabricated, and the parametric studies which were done was primarily to measure the pressure distribution over the helideck with the island in position, and shift the island and see what is the effect both ways, to see if it does have an effect on the bubble. And then we basically tried to see, because the studies on the aircraft carrier without the island showed that the bubble primarily was formed because of the vortices generated due to this port notch. Starboard notch does not have any significant influence, but this notch and the bow, if they interact, they create what we see as a bubble effect. And this, when the island is placed, it magnifies the bubble effect, because the vortex generated due to the island interact with these vortices generated at the bow and the port notch and create the bubble effect along the glide path. So this is basically the plan how to carry out the work, but I'm not going into detail of this because it will take too much. I've exceeded my time, it looks like. Can I take another 5 minutes? Hello?
Yes, Professor Singh, 5 minutes is fine. Thank you.
Okay. So these are the results which we obtained for the pressure and compared them with CFD, and it nearly matched for the Sst Turbulence Model, both with the island, without the island, and with the raised island. The velocities were measured using PIV at different levels, so that it became a benchmark data for doing any validation studies using CFD. And having done all the analysis, Basically the additional studies which were done, when we found that the vortex generation at different levels was creating a problem, we tried to suppress these vortex by providing or changing the geometry of the aircraft carrier. Like if you see, we are trying to suppress the vortex by providing plates at all these surfaces so that they suppress the vortex generation. These were all passive flow devices tried to suppress the system, and then also identifying the location of the island, lifting the island. So this basically was done, and it was found that the providing the island with aligning it with the flow direction and lifting the island a little bit helped significantly in suppressing or lowering the deficit of velocity, and also pushing it down to about 1,500 meters downstream of the cone to get the bubble effect, so that the pilot had enough time to land. So these are some of the studies which have been done, and this table highlights in general the findings of each parameter which has been investigated. Some work which is at the moment going on is the self-propelling submerged bodies. It is basically to underwater vehicles, and we are trying to see, generally we do study these using tow tanks, and we are doing it in the wind tunnel, where we are trying to measure the pressure distribution over the body and change the effect of hull shape, and then evaluate the hydrodynamic coefficients. So presently the pressures have been measured and validation has been done. And this is what the setup was done. So you can see the body, how we held it, and what are the pressure taps provided to measure the pressure distribution over the body. And you see the results, how well they match the CFD results with the experimental results. Reasonably, the maximum error is about 10%. So this work is also going on. And I would say that we have been able to get a significant amount of insight into the flow structure of different marine vehicles. And this will go a long way in helping the Indian Navy, and also to do some initial studies at the design stage itself to improve some of the superstructures which have to go on to the ship. Thank you very much. Sorry for have taken slightly longer time. Any questions, please?
So first of all, thank you very much, Professor Singh. It was a very, very interesting journey through your 25 plus years of research in aerodynamics for the Indian Navy. I have a few questions myself, but first, can I express my thanks, and I'm sure the audience would normally, if they were in the same room with you, applaud. So I'm sure I'm clapping over here. And I think the rest of the participants will be doing the same thing in their own locations. Before I go into the floor, I can see there are questions on the floor. Before I go to the floor, I'd like to invite Mr. Rai to ask a few questions. He hinted at the beginning, at the start of our session, that he has some, if you like, ideas and which he would like to share, and maybe one or two questions that follow on from those ideas. So, Mr. Rai, can I please invite you to A, unmute yourself, and B, to have your video on as well, please.
Yeah, thank you, Mr. Shenoi. Actually, I had question. I thought you should ask the participants first. But before I start, first, my compliments to Professor Singh for extensive work done and very nice presentation. At the outset, I will admit I learned many things. So I have been on few of the Navy vessels, including aircraft carriers, frigates, etc., particularly and including when they were under repair or being built either in Cochin shipyard or at Majgaon dock. But many things which Dr. Singh said today, I can correlate with the commercial shipping as well. So I would like to first ask a general question, because as I said in my brief earlier, I'm still involved in many things, and we are looking into research work, particularly related to these environmental issues and global warming.
Sir.
We can approach IITs. I mean, I can go through the Ministry of Shipping or even to the Indian administration. But to my mind, IITs are basically the hub of the education center. So how you will help us if we approach you, whether you can do some research work on the environmental issues, global warming, finding alternative fuels, etc. Because till date, to my knowledge, most of the research in this field is we are only getting from what Europe or Western countries are doing. But not much has been done in India. And this is a very serious issue. So just can you enlighten Dr. Singh that how IITs can help us?
Sir, I will just share one thing. One of the groups in our department itself is doing a study on the environmental effect of in IIT Delhi, in Delhi, not Delhi, the Delhi pollution created by road vehicles. So there are studies where they will basically identify how does the pollution spread in the atmosphere and what are the remedies which can be tried to suppress that pollution. So even we have an atmospheric science which is doing a lot of work in the area of environment, and they will be willing to help. We have a Center of Energy Studies which is working on alternative fuels. And currently they are working a lot with hydrogen. That's what I know of. So there's a lot of work per se being undertaken at IIT Delhi through sponsored projects. A lot of work. See, and most of the IITs, I would not say only IIT Delhi, the sponsored projects which institutes like IITs get from different agencies is to the tune of about 400 plus crores every year. So a lot of research is going on. We have been recently, there is a center which has been set up by DRDO to carry out research in some specific areas. The armor is one, where they are trying to develop the armor which is lighter in weight, and they have been already achieved to reduce the weight by from 2.5 kg and still with the same capabilities as the earlier armor. So there is a lot of work going on. See, it's only,
I appreciate saying that I know IITs are rated very high and they indeed are doing a lot of work. But somehow I find in our commercial shipping, we have not been able to take full advantage of the facilities or the talent which IITs have today. I was trying to introduce that how I can go to Minister of Shipping or Indian administration to make use of the facilities that IITs can extend to us.
IITs will be most willing to do it. I will tell you the reasons where the problems are. One of the basic problems, recently there was a tender which was floated and which said that you basically use a scale of 1:50. And this is from L&T. There is no tunnel except for IC Bangalore, and they will not be able to justify. I cannot do a 1:50 scale model. If they had left this to us, by the scale can be selected, but it should produce the results equivalent to this Reynolds number, I can still understand that. But if they impose a condition like this, any system, then we cannot help out.
So lastly, before I will give platform to others, I mean, you did so much of work with aerodynamics, smoke nuisance, etc. They're also part of our commercial shipping because smoke has always been a cause of worry, particularly on Indian commercial tankers, because we found many times unburned fuel resulted into sparking on decks and cause of likely fire, etc. So my question was that you've done so much of research onto this. I'm sure this you must have passed on to the shipyards or the prospective Indian Navy, etc. Has any of this been implemented or executed?
See, the smoke nuisance problem, they did implement it. INS Delhi then only succeeded to go around with the same efficiency as it was designed for. So this is basically, it is possible. See, most of the suggestions you will see, which is the research which we have done, will penetrate into the commercial aspects.
Thank you so much. Mr. Shenoi, I think I will do with that. If anything further, I will come later also.
Okay, thank you, Mr. Rai. Thank you for starting us off on the question and answer session. I'm looking at the Q&A box on this Zoom link, and I can see some interesting points raised by S. Ramanathan, and I wonder whether you could please unmute yourself and also share your video, and please put forward your viewpoint and any questions to Professor Singh.
Yes, can you hear me?
Yes, if you've got a camera that's switched off, and if it's possible to switch on the camera, it'll be very good.
Okay. Anyway, as I speak, I will try to come on the video.
Okay.
So anyway, it was a very interesting topic. And I had raised a question beforehand because I know that there is not enough time for you to type that question. Actually, a lot of questions has already been answered by Professor. Now, I would like to know, other than the aircraft carriers and defense, have you done any other projects of notable size and proportions for a successful data analysis and
So we have basically done a lot of wind tunnel studies because lately, other than the Navy, there are a lot of industries which have been approaching us to the problem of chimneys how does the structural and the effect of the environmental buildings and the flow which takes place over the chimneys, and have given them a lot of data for bending by doing strain gauge, mounting strain gauges on chimneys. We have tested a lot of buildings. If you are aware, the Lakshmi Nagar district center, there is a building in Delhi, which is called the Scope Tower, was tested in our wind tunnel, and the design was changed to accommodate the effects. We also, the roof of the Talkotora garden, the swimming pool roof, was tested in our wind tunnel. So we have been doing a lot of work for the industry. Plus the research has been going on. As one of the things which I did not present, which is basically related to the aircraft. So basically, if we have the exhaust of even the helicopters, if you see the exhaust, it is basically a step diffuser with cutouts across the circumference at different stages. We have seen and we have suggested, and even we have, this is the normal course of studies which we have done as students, and we have even got a patent for that design which we have done. And similarly, in the area of flow meters, I've done a lot of work. So that is how research is. So if you have a specific area in mind, please feel free to ask.
That do you have a follow-up on that?
Question is on the marine. I don't think it is appropriate for me to ask out of the box. But anyway, it was a very good topic, and thank you so much.
Thank you. Thank you for your question, Mr. Ramanathan. So the floor is open to you all. So either you could raise your hand. There's a raise hand feature that's available, or you could type very briefly even the phrase "I have a question," and that in the Q&A box, and I will be able to see that. And until the time that someone raises a hand, I wonder whether Professor Singh, you could take a question from me.
Yes,
and the question is this, it's a general question. Could you tell us a little bit about what features we can understand and model in a wind tunnel, as opposed to, for example, in a towing tank? So you mentioned, some of the bodies like the submersible that, you could do certain modeling for, say, Reynolds numbers effects and so on in a wind tunnel. So could you tell us the pros and cons of fully submerged objects being done in wind tunnels as opposed to in a towing tank or in a flume?
Sir, if you see what we need to ensure, even in a wind tunnel, the body is fully submerged. Only the fluid has changed. It has changed from, in a towing tank, from water to air. The only difference is how do you match the Reynolds number. So obviously matching the Reynolds number will become mitigate. You will have to perform the experiments so that Reynolds number at least is in the range where the effect of Reynolds number is not there. So the velocities at which you will tend to operate in a wind tunnel may be at a higher velocity than in a towing tank. That is the prime. The only effect which we cannot simulate in the wind tunnel per se is the pressure or the water head which will be there in the towing tank, if at all. Otherwise, it is the criteria, and we cannot talk in terms of the fraud number practically. But otherwise, if we talk of the dynamics, if we can do the Reynolds number matching, or at least reach the Reynolds number, after which the flow characteristics are not affected, the results will, on normalized, will behave the same.
Okay, I think I've got that. And I'm again looking at the audience, and this is a new field for me. Normally, seminars are held in person, and I can see the faces and people's hands and eyes and so on. I can see one hand raised.
Has been bad.
I can see one hand raised, and Mr. Dasgupta has got his hand. Over to you.
Yeah, thank you very much, Professor Singh. There's first a general information which I wish to share with everybody here who are attending. The IMO is going to hold the next MEPC 77. And for MEPC 77, Mr. Rai would definitely know, ICS and many other corporate entities, they have come up with a document with the request for the research work which is required to be carried out for the future, and seeking the financial support through IMRB. So that is a very exhaustive list. If you have seen that document, which is published at IMO Docs, it's a very exhaustive list. It's a pity that India does not figure in that. We can definitely carry out some of the research which is possible to be carried out here. And we should also participate in that research work. And possibly through IITs and IMU, we can, the different campuses, we can, present a paper, possibly together with Institution of Marine Engineers, offering the kind of research that we can carry it out in India. It's an open document. People can just download it. And there are a lot of issues which can be addressed there. So this is the first part of my information. It's not a question. The second part is, personally, what we have seen is there are certain ships on which the aerodynamics becomes very important, especially for LNG carriers, which are involved in ship-to-ship transfer in open seas, both being floating. Because LNG carriers have a fairly high amount of air draft, that is the draft above, somewhat like the aircraft carrier or a Navy ship. Compared to other bulk carriers, LNG carriers have a much higher air draft, and therefore during the ship-to-ship transfer, the mooring loads which come on are very difficult to estimate. So we found it quite difficult to estimate those mooring loads optimally, and the mooring system design also for ship-to-ship transfer. This is one area where the proper aerodynamic studies, supported with parametric formulation for estimation of the mooring loads, can be of great help. So this is one area which I think can be looked into very well. That's all from me. Thank you very much.
Thank you. I think the problem which you are talking of will be easy to handle.
Okay.
It's not too difficult to handle. With the type of capabilities now which are available in institutes, they should be able to do most of the things just by doing CFD studies.
Yes, thank you. Thank you very much, sir. I'm sure Professor Shenoi and Mr. Rai would be able to understand what I'm aiming for. Thank you.
Thank you for that, Mr. Dasgupta. Again, looking at the floor, as much as I can see with my limited knowledge of Zoom. So I'll wait for more hands or more text to appear in the Q&A or the chat box. But while I'm waiting for this text to appear, I've got another question, if I may, Professor Singh, and that concerns the modeling. So
Yes,
you've done modeling using wind tunnels with experimental techniques and using computational techniques.
Good.
Now,
Yes.
wind tunnel testing can be limiting. It's expensive because
It's
time in the wind
expensive,
tunnel is
time
expensive,
consuming.
time consuming, and you can only do certain number of tests. You can't do many varieties. You're limited. So because of the expense, you have to focus in on a few things. Similarly, computational fluid dynamics, although we have now the computational power increasing quite a lot, and we have got the speeds going up, the capacity, storage capacity is going up. We can do many processes in parallel, so the computational side is increasing and getting much more refined. But nevertheless, there are limitations in what one can do with CFD as well. Sure. I wonder what your thoughts are. Sorry, did I say something wrong?
Sure, what you're saying is absolutely right.
Okay, so what I was leading to is, what are your thoughts? And particularly for ships, as you've shown us, the ship problem is very, very complex. Probably more so than in aircraft or buildings, because we are operating at the interface of two very dissimilar two dissimilar fluids. And we've got surface effects and free surface effects and all kinds of other things, which make a difference in terms of how ships and things on ships behave as opposed to on land or fully in air. So given these sort of features, I wonder what your thoughts are of hybridizing, what advances are possible in fluid dynamics, such that we can do some analytical studies using some elements of computational sort of techniques and some elements of experimental techniques. And I wonder whether there's space for work for quick analysis and quick assessment to feed into design. Your thoughts, sir?
Sir, if I understood your question correctly, what you are saying is, can there be a mix of different techniques to help the designers at the initial stage?
Absolutely, because the kind of things that we've heard today in the main are responsive. They're sort of in response to some problem. But is there some way in which we can help, or you can suggest that if you do this kind of technique at an early design stage, you will get a good design?
So, sir, that's what most of the studies which we have basically tried to show and do is with an aim for the Indian Navy to start looking at some form of preliminary CFD analysis for the structures which they think they are going to put up on the ships, and get a gross flow feature and see how they can improve that flow feature by modifying the body, which also could be studied by the CFD initially. Because CFD today, with the type of turbulence models which have been developed, we have seen that doing an unstudy analysis only does about 2 to 3% effect on the actual flow feature. The flow feature, average flow feature, still statistically remains the same. So, yes, slowly and steadily, as you rightly said, the computer storage, computer power is increasing. And I remember a statement which was given by Professor Spalding sometime way back in, when was it? In the 60s, 20th century, 1960, 61, that we will be able to solve the exact problem using CFD by 2050. So he was a visionary who could see when so because if we are able to do the DNS analysis, the direct numerical simulations, we really don't need to do experiments. We will reach that stage, but there is still some years to go.
Yes, I mean, I remember in my undergraduate lectures, and I'm going back to the early 1970s, when my teacher in aerodynamics talked about a numerical towing tank. Not a physical towing tank, a numerical towing tank. And I'm still waiting for that numerical towing tank. But I'm sure that by 2050, we will be there or thereabouts, in a sense.
Absolutely.
But again, as I say, I'm looking for any raised hands or text. And I can see that perhaps your talk and the Q&A that came after the talk has helped to both widen and deepen the lecture. So I'd like to just conclude the session to say what a delight it was and how informative and how educational it was to listen to you, for you to share some of your thoughts of what you've learned over the last many years doing this work for and with the Indian Navy. Looking at aerodynamics of ship superstructures, how the airflow affects the performance of the engines through the intake, and how the safety of the helicopters when the landing is affected, and also how, for example, the aircraft, when they come to land on aircraft carriers, how their sort of path and how their landing can be, better ensured, and how basically your studies can help improve the designs of ships. So I think ultimately as naval architects, so in the institution of naval architects, we're looking for any help that we can get from all professionals in different areas to see how we can do a better design of ships, how that can be produced better, how ships can be operated better. And I think your lecture today has helped us in understanding how aerodynamic studies can actually influence and improve the ship designs for the Navy. And I'm sure there are lessons in what you've done for the merchant Navy as well. So we will take these lessons from you. Your work is out in the public domain. So those who want to read about the kind of things in more detail, I'm sure can visit your site, look at the PhD theses of your students, the papers that you've published. And if there are any questions, I'm sure that your contact details are pretty prominently displayed on the IIT Delhi website, so they can connect with you. And the kind of questions that came from Mr. Ryan, so on, I'm pretty sure that you in IIT Delhi and other universities and IITs in India can help the maritime industry quite nicely. So with that, I'd like, again, all the audience to join me once again in thanking you, Professor Singh, and you, Mr. Rai, for being with us, for sharing your thoughts, for sharing your wisdom, your knowledge with all of us. So thank you very much.
Thank you for giving me an opportunity to interact with the Institution of Naval Architects. Thank you.
Not at all. And I now hand you back to Akshay and to...
Yeah, Professor Shenoi, good evening. I am Commander Manor Kapli. I'll take it over from INA's behalf. This is my present duty to wind up. And I'm very, very happy to attend this session today because I was fortunate to be a student of Professor Sst Singh at IIT Delhi. All the Indian Navy's naval architects are his students after the 80s. And we have all seen his work, which has been done. When the first study was presented about the destroyer, I was a part of that study when the results were presented by Professor Singh. So it was a live class for me after many, many years. And sir, it was really, really enjoyable. The way you explained everything, why the question did not come, that is because there was a lot of clarity in whatever you explained. And there was no scope for any kind of doubt. So applied mechanics, IIT Delhi does not have any naval architectural department, but still IIT Delhi produces naval architects, and that is done through applied mechanics department. It's a very, very unique model developed by IIT Delhi for Indian Navy. I'm also very proud of my naval colleagues who have done PhD under Professor Singh in this subject, that is aerodynamics. And sir, just for your information, you mentioned about your student, Professor Vijay Kumar from IIT Chennai. So in this forum, he was there a couple of sessions back, where he presented what work is being carried out in hydrodynamics as well as in aerodynamics at IIT Chennai. Actually, he combined hydrodynamics at IIT Chennai and aerodynamics at IIT Delhi. That is how he presented it. And that was also a very, very well-received session by the audience. Thank you very much, sir. We are really grateful to you for a very, very enlightening session. Mr. Roy has been our close friend and close colleague, and has always been a supporter of Institution of Naval Architects. Whenever we talk about doing anything joint with IME, the first name which flashes into our minds is always Mr. Roy. He is so approachable, so friendly, and we remember the good days when we did Inmarco innovation with him, the interactions which we had with SNEMI, with RENA, and many other such bodies. And we will continue to do that with the help of Mr. Rai. So it was a very pleasant thing to have you here with us once again, and we'll continue to be in touch together. Professor Shenoi has been a constant presence in INA technical sessions, and his presence itself inspires us a lot. And for the younger members of our audience, he is a role model and he is an inspiration. The way he puts across his thoughts, and the way today also he has conducted a session, it's really very, very enjoyable. And thank you, Professor Shenoi. Thank you very much. Our most valuable asset is our audience. And today we had almost 57 people joining, some on Zoom and some on YouTube. So audience, well done. Thank you so much. And we started this session with remembrance of Mr. Sushant Basu. So I am thankful to Professor S.M. Mishra, Mr. Dilip Sawant, our senior colleagues, as well as Mr. Jyotishman Dasgupta. I'm also thankful to the family of Mr. Basu, who were able to join us in the remembrance session. My executive committee colleague, Commodore Sujit Bakshi, has been very regular, as well as he has maintained the tempo of INA webinars over the last couple of months with unmatched regularity. Every month, he has been able to arrange some or the other interesting technical talk. We look forward to the next technical talk in the month of September. And Commodore Sujit Bakshi, well done, please keep it up. I thank all of my colleagues in INA as well as in INA Executive Committee who put in a lot of time and energy to keep this institution alive. So thank you so much, everybody. Have a safe time, take all precautions, have a happy time. There is no relaxation, or there is no time to down our guard against the pandemic. With this, I wish everybody a very happy time ahead. Thank you so much.
Thank you. Thank you so much.